Just one comment. Can you all hear me? Just one comment to Bob Derogish's question is, big corporations have big entrenched people with empires, and security is very often a phantom issue because the cloud is a threat to those empires. So I'm here to talk about what we went on to assess around the design-centered workflow. And I go to events about twice a year, and someone in the audience will erupt with a rant about CAD, okay? And I'll get to that in a second. So this is our chart, similar to what was just shown, design-centered workflow, and I've summarized that as enabling the engineered design. So we're looking at some things here that are difficulties, and then the benefits in time, quality, cost, and the business case. You know, time, quality, cost, speed to market, all of those are positive for the business case. The question is, and this came up at Assess, is whose design is it anyway? You know, when did drafting become design? How did we let them stop talking about computer-aided drafting and start talking about computer-aided design? Because the CAD model is not a full description of the design. People talk about the tyranny of CAD. It turns out that when we go to companies at SimData and we talk about how the engineering process works, we still very often run into, they have a stage gate product development process, and they review what's going on, and then they make decisions, and you ask them, well, do you do simulation? Is simulation required to make those decisions? And it turns out it's not, because the decision that they're trying to make is, can they commit more money for manufacturing? So manufacturing is the long lead item, and that's how they pace their product development. So there's something of a consensus that 3D CAD, abetted by PDM perhaps, was a distraction that caused a resequencing and bad resequencing of the process of engineering. We got away from doing engineering and then doing the drawings to doing the drawings and then evaluating them to see if they worked. And I think, and others do, that now there's an opportunity to fix this and have what we might call, you know, everyone has something driven something, so I call this engineering driven design. The elements of a solution really is looking at engineering the systems and fixing the development process. So it's a focus on engineering the system, and I didn't say systems engineering, because I think there are issues with systems engineering as it is practiced that need to be fixed as well. We need requirements that are traceable and verifiable, and maybe, I think, the organizing framework for much of your information. And I guess it's a frustration to me that we've been talking about connecting requirements to simulations and connecting requirements to CAD so that we can understand the implications of when a requirement changes, what needs to happen, when the CAD changes, what needs to, how does that, perhaps which requirements does that impact, and what simulations need to be revisited. And I think we just don't have that today, and we've been talking about it for at least a decade. I think it was mentioned here, we need to have this idea that we have hierarchies of models of varying fidelity and appropriate fidelity so that we can deal with fuzzy definitions of what the design is, and we don't have to get to complete CAD to say we have a design and we can now make some decisions. We need model-based collaboration. I think that the way most companies manage their models, their systems models, the MATLAB stuff and others, is really not conducive to using those models for collaboration. Very often the model is just a big blob, it belongs to one user, and if you want a question answered, you have to go see that person. And so the question of whether the model is fit for purpose for a particular investigation is just not known. And I think the companies and perhaps the industry can help with how should one manage your models with the intent that they can be used for model-based systems engineering and collaboration. And then, by the way, please bring us the data management systems that will help us to do that. There's also the idea that we need to be optimizing the value of the data. So if you touch the data, it's either to get information or to add value to the data, excuse the typo, or to access information. We see a lot of effort that just goes into moving data around, translating it between systems, and really not adding to the information. And Sunoco is the official fuel of NASCAR. I think that Moore's Law is the official fuel of engineering-driven design, that with improvements in computer capacity, as you put this together, over time it will just get better and better and more capable. And how did that get in there? We need, as was mentioned, embedded simulation, the democratization and optimization throughout the process. So the simulation is there to guide the designer and not be obtrusive and not require special arcane knowledge on the designer's part. So here's the systems of engineering V on the right, the traditional CAE for product validation. The right, of course, is the integration from component design. Companies know how to do that. The question is, how can we attack the left-hand side of the V, where we're looking at multidiscipline trade-offs with modeling and simulation. We're doing trade studies and optimization, and by the way, also looking at collaboration across the domains. And this is a very old slide. This is probably 15 years old. It's from the original Nkosi. And it shows the view that what we're trying to do is get at where everyone's looking at least conceptually or logically, the same data, and people have a view into the data that can be shared, and they can do the collaboration without having either copies of the data or information in documents that belong to silos and everyone thinks is out of date. Another old slide, this is something from Dimitri Mavris, probably 15 years old. They're at Georgia Tech. They've got their systems development lab where they put together these hierarchies of models for collaboration, and they can use them to make decisions in real time and very much cross-domain and multidiscipline kinds of decisions. We at SimData do this stuff, and so I've thrown in a couple of SimData slides, and really what we're talking about is a vision for a platform that enables this upfront model-based conceptual engineering. What are the components? What do you need? And there are additional slides if anyone is interested in who would the user community be and what would the business benefits for solution providers be. So putting it all together, this is another slide from SimData. I'm not going to go through it, but it talks about what is a platform that enables this kind of upfront conceptual engineering going to look like. And the closing comments, as I said, it is somewhat frustrating that many of these ideas and requirements are not new, and yet we don't have them. I think there was an interesting sidebar at the Assess conference where Mary Fortier was saying, of GM, was saying, I've been talking about these requirements for 3 to 5 years, and nothing happened, and one of the vendors basically told her, this stuff is real hard, and the market is real small, and we're not going to do it, which is frustrating. As I said, requirements must be connected to mechanical designs. I think that the mechanical design community are the last ones to come belly up to the bar and say we've got to do systems engineering. We need optimization for fuzzy and incomplete definitions of the design. You know, do optimization on geometry when you don't have all the geometry. We need geometry for X, where X is not manufacturing. The preoccupation with we do CAD for manufacturing needs to change somewhat to we generate geometry to do simulations to gain understanding to then define what the manufactured of physical geometry really should be. As I said, we need proper management of system models with versions and configurations and a lot of best practices and hygiene among how companies actually go about this. We need these models for collaboration, and I think we should get back to doing engineering before we do drafting.
Thank you, Keith. So I want to point out a couple of things. First of all, Keith's presentation and Steve's presentation that kicked it off, the topics were very similar. As a matter of fact, we spent probably half of the discussion time at Assess talking about these two topics together and debating as to what is really different about them. And Steve, the slide that you and Tapankar came up with about how that horizontal bar of where analysis is and where we want to be doing it matches really, really well. And I'd love to see that tied into Keith's a typical V analysis. But the key difference is what Steve was talking about was moving from the idea and requirements to an idea of what we should be doing. And what Keith is doing is saying, how does the design influenced by the analysis? And those are the key fundamental differences.